Hello? Okay.
Hello.
Yeah. Okay. So, I'm Vagrant.
I'm Holger.
We look like that and that. We've been doing some stuff for some years. I've been catching up to Holger. So we've been working on the Reproducible Builds project.
So when we talk about, say, reproducible, we mean this definition. A build is reproducible if given the same source, build environment, and build instructions, any party can create bit-by-bit identical copies of specified artifacts. So not just reproducible in the sense of repeatable, but that the result is bit-by-bit the same.
So I'm going to kind of take us through a little story and going to touch on some issues of reproducible builds along the way. I'm kind of dressing this up in the story of The Hobbit. How many of you are familiar with The Hobbit? Yeah? Okay, great. I don't know how well I'll do. We're kind of experimenting with this, but I'm playing around with it. Thanks for entertaining us, and hopefully we'll entertain you. So you're a little consultant. You've got your little home development business going. You got your development environment set up kind of just the way you like it. Everything's going smoothly. The day is good. And you're thinking, don't have any contracts right now, so I'm just going to sit here and have some nice tea, sit back, enjoy the morning. And somebody shows up. And they show up, and they're kind of, it's like an old friend. You kind of knew a family friend or something, and they've got this, they invite some other people over, they show up, and they're not just there to like hang out, they've got a contract for you. So they got this deal that they want some software to be built, and they want it to come out the same every single time. And you look it over, and you don't really have any other contracts going, and if you want to eat the way you like to normally eat, you need the money coming in, right? So you're thinking, you sign off, you have a big party, and you set out on your next consultant adventure. So you start on the trail. They you got to commute to where they're going to be working. So you set out on your trail, and you're hiking along, and you're thinking about breakfast, and maybe some tapioca, some pão de queijo, and so you're hungry, you're tired. You think about all of the other projects you've worked with and worked on over the years, and you're pretty happy with how things are going, but you're still quite hungry. And so you begin.
These are the projects currently working on reproducible builds. We know there are more, and if you want your project listed there, if you work on it, contact us. We're happy to have more projects listed on our project page.
So again, you set out on your journey. Some people, you get on the internet and they tell you, this could never work. How could you possibly get this to work? You struggle with it. You figure out some way, you're fighting with the software a bit, you manage to make it past all the trolls. Then you find yourself in a deep problem. Some people might refer to this as a rabbit hole. This is a deep, dark cave. You're stumbling around in the dark. You don't know what's going on. But, you're working on this software project, you're building it, and there are all these issues that keep coming out, and you go deeper and deeper into the cave. And you've just got this mysterious binary blob. You have no idea why this blob comes out different than this other one. But you stumble upon something in the cave. And, it helps you out of the current situation. But so you find a little bit of hardware to help you work out through the problems. And everything's great. But you find yourself staring into a dark forest, and you're wondering, I've got these two binaries, they're not coming out the same. How can I look deeper into these issues? And so you hope for some tools to come your way. Maybe you encounter some bugs. You're working on some problems, but eventually you get to the heart of the matter. some three-letter agency has devoured your entire project. They've injected themselves into every path of every tool that you might conceptually use. But eventually you find with your allies, your friends, all of the tools to help you produce your objects reproducibly. And you get back home. But somebody's watching. And so you're sitting at home, you think it's over. Maybe it is.
Or maybe it isn't. So, once upon a time, in the 1997, there was the first mail on a Debian mailing list. Somebody suggested we should do reproducible builds. And people said, nah. And the same in 2000 and 2003. Were like 2 or 3 mails on the thread, and it was considered impossible. And in 2011 and 2012, Bitcoin and Tor browser created reproducible builds of their clients. Bitcoin was worth $400 million, I think, at that time, and the developers were afraid if somebody would create a Trojan Bitcoin client, distribute it, steal all the money, they could not prove that it has not been them. So that's why they made reproducible builds back then. And that was quite wow. Like the Tor browser is 50 megabytes or something, the binary. And it was bit by bit identical. And historically, every software was reproducible. Like when there was 4K or 2K, the developers know every bit they put in. And yeah, every bit was known. And even in the early 90s, the GNU toolchain was made reproducible on 10 or 9 architectures. But everybody forgot, including the GNU developers. So they were really surprised, or one person remembered, can't get this name, but basically the whole industry or everybody, the whole community, everybody forgot that reproducible builds were possible. And then in 2013, after this Tor browser and Bitcoin and some people in Debian brainstormed, had a first session at DebConf 13 and thought, we could start this, investigate this. And in 2013, we started systematic testings of the Debian packages, classification, finding out the issues, and started a weekly blog, which we kept for 200 weeks, so 4 years. And only since 3 months, we're writing a monthly blog, because weekly blog is just too much traffic and people don't read it, so we switched to this monthly format. And a lot of things happened. And in 2017, it became part of Debian policy. Policy now says packages should be reproducible. So it's a normal bug in Debian if a package is non-reproducible. But it's a bug now. And that was quite some success. And I hope, I don't know what verb to use, that in 2023, the time is hopefully ripe for having must in policy. So then Debian releases will only contain reproducible packages. And 4 years seems to be a lot, but this is the graph of reproducible packages in Debian unstable. So this is October 2014 till yesterday or something, last week. And the green packages are the reproducible ones, the orange ones are the unreproducible ones, and the red ones are failing to build. And that's 93% at the end, which is pretty good. Well, this year is not 93% for some other reasons, but we are at 93% in Buster and Bullseye. But that also means there's 7% unreproducible packages. And since then, we have this test set up not only for Debian, but we also test Arch Linux, FreeBSD, NetBSD, OpenWRT, Core Boot, and F-Droid. And since end of last year, we have a shared database, so it's all stored in the SQL database, and we're working on creating the web pages for the other projects as nicely as Debian. If some of you knows SQL, Alchemy, Python, and PyStash, which is Moustache templates, and has interest to help out, that would be great. We are sharing the issues between the project because it's usually, if the software is unreproducible in Debian, it has the same problems in Arch Linux. We share the patches and we also try to get them upstream. And as I already said, we have a monthly blog, our monthly blog where we report about these things. The next blog is going to come out tomorrow. And even more collaboration is possible, we think. We want more collaboration because it's really a big problem and it's not a Debian problem or something. And what's causing unreproducibilities? It's timestamps.
Also timestamps.
Then there are timestamps.
And timestamps.
And more timestamps. If you leave timestamps in your build, it's wrong. It's either it's in the build, this build was made on this date, it's meaningless. This build is made from this version of the source, it's meaningful. These dependencies were used as meaningful, but not the date. And also documentation also include. This documentation was built on this date. Doesn't mean anything. This documentation was last modified, means something. And for this, we've developed source date epoch, which is a specification, which is the last modification of the source counted since the epoch, so the January 1st, 1970. And this has been adopted by 70 projects, like GCC supports it, PyDoc supports it, 70 projects. Then the build path is also often embedded, for which we have the simple solution, the rebuild has to be done in the same build path. Because for distributions, they usually build in TMP build and then some random path to rebuild, just use the same random path. It's more stupid if I build in home Holger, then you also need to build in home Holger. That sucks, so we want to fix it, but at the moment, that's the way it is. Then time zones and locales also get leaked into build products, so set it to UTC. That's the locale to English. And there's hundreds of classes of courses. Like we've identified 250 different courses because of the different similar classes are in different systems. Like these timestamps are embedded in 20 systems, locales are embedded somewhere. So we've all classified this and then have some software is affected by different issues. And it's usually fun to discover these things. Because you look at the software and then find, sometimes it's annoying. We also find, we find software which is sometimes unreproducible, like on 3% of all the build is unreproducible. That is hard to find, but it's really satisfying if you find it. And to find the stuff, we invented Diffoscope, which is a recursive and human-readable diff. So it will go recursively. It was started with 2 Debian packages, but now you can give it 2 objects, 2 directories, 2 zip files, to anything. So it will go whatever. You have a Debian package, there's inside an R archive, inside it there's 2 tar archives, and the tar archive is a PDF, and in the PDF is an image, and if you build the software twice, all this gets created, but there's a timestamp in the image. And Diffoscope will nicely just show the timestamp so you can see, aha, this file there is different. It's not used for determining whether something is unreproducible. For that, we just compare the hash, and if the hash is different, then it's unreproducible. This tool is good for finding out why. And it's available on all major distros. It's also available on PyPy. It's maintained in Git. It uses Python. If you install it on Debian and install with recommend, it will install about 2 GB of software because it supports quite some file formats. This is a diff, so it shows here some SQLite database, I think, and there's the diff in some values and shows exactly how they diff. Here's an example where the version number is different, 506 and 507. And this is why it needs 2 GB of recommends, because it can work with many file types. You can give it 2 ISOs. Like Tails is reproducible now. The one how big is the tails? ISO 1 gigabyte or something? Diffoscope can compare that. And it will find nothing because they're reproducible now. If some file format is not supported, please send the file a bug. We really want to get this fixed. Whatever obscure object format, anything, we want Diffoscope to be able to compare it. You can also try Diffoscope without installing it, just this web service that you upload 2 objects and will compare it for you. And it's also useful beyond reproducible builds. You can check security updates and see whether only this part has changed which should have changed. For that it's really useful, or for development. When you do some changes with some tool chain, working on your sources, modifying, you can check whether it's really doing the change you want to. Then we have another tool which is called reprotest, and that builds something twice with as many variations as possible to see if something is unreproducible. It's basically our test setup in a smaller variant. And it can then reduce the variation. So it first builds with all the variation, and then it stops varying the username. And if then it finds, oh, it's reproducible now, then you know it's caused by the username. Then it stops varying the locale, and if it's reproducible then you know it's because of the locale, and so on. And the problem with reprotested, it's unmaintained. The person who wrote it left the project, and it's quite sophisticated Python code with a bit of C, and we need somebody who takes over maintenance of the tool. So if you are bored, interesting, reprotest. And then this 93% is a lie. Because getting software reproducible in theory is just 33% of the way. It's 1/3 of the things we have to do. This 93% is about making this in theory, enabling the software that you can build it reproducible. The next are about doing this in practice, which means changing the workflows for distros, the tools and workflows. That's technically easy, but in practice it's not. For SUSE, I can say SUSE needs to enable 3 RPM macros, then OpenSUSE will be 93% in practice. They have not done this out of fear of changing the build process. In Debian, there has been changes, or there needs to be changes to the way how the release team and FTP master work, and we can prototype this, but then we need to give it to these teams, and the teams might have other reasons also. So this is our changing the distro in practice to use our tools is the second step. And this is different for each distro, and also the last third is again different for each distro. And that's divided into these questions. It's about distributing trust. Like we have built these hashes, and there's this hash which should be it, and then we need rebuilders who certify, okay, I can rebuild it too. But then there's the question, which of these rebuilders do you trust? So Debian builds their software once, and then whatever Amnesty International builds it, and the CIA builds it, and whatever the Russian army and the Korean army, and whom of them these do you want to trust and how? And all this has not really been done yet. Also, we want to enable everyone to independently verify that the software is reproducible. How will users do that? There's 2 designs. There's In Toto from the New York University, which does this, and Software Transparency from Benjamin Hoffman, which is aimed at Debian. And they implement some designs, but again, we need to get this, in this case, into Debian. But these solutions also need to be made for SUSE, for OpenWRT, for other things, so that users can actually verify this. And best without all the users rebuilding everything, but having some trusted rebuilders or a set of trusted rebuilders. So this is all research, because we spend a lot of time on this 93%, and we are still not there. So, and to increase our collaboration, we do summits. We've done one every year, so we've done them in Athens, Berlin and Paris, where there were about 50 people from 25 projects. and we exchange ideas and discuss these problems. We're planning one this year in Marrakesh, in Morocco, and there will be the next one after that, where I could imagine maybe to do it in Mexico, in Brazil, maybe in Africa again, but probably not in Europe again. And collaboration has really nice results. This was a present I got this year. I was very happy about this. It's Jelle from Arch Linux. And
so all of this work, we stand on the work of others. Oh dear. What happened? Okay. Didn't see anything. Oh no.
what are you doing?
I'm working on a keyboard. All right, you work that part. So, we're here because of the work of a lot of other people, a lot of other men and women and others. We're here because of the elves and dwarves, because of the wizards and hobbits, and beings beyond our imagination. And we welcome you. We welcome you all. We welcome free software, and we would like it to be reproducible. Can you help us?
So yeah, we made this 93% of the first third. And that sounds good, but it means there's still 2,100 source packages where we don't know what the problem is. Or we have 200 patches, I think, but so it's still 1,800 packages. So will still take some time. That's why I said 2023. We'll 2 more Debian releases, and then we can say, okay, we don't, if it's unreproducible, we don't care about it. But at the moment, whatever Perl is unreproducible and apt is unreproducible, and we kind of need those packages. And then that's currently, and there's new software basically every hour. So we always need to look also new software versions that can be unreproducibly introduced. And yeah, the rest is more blurry. Tails has done it, but no big project, no distro with 10,000 packages. It's easy for 1 or 2 packages, but getting that for 10,000 packages is way more difficult. And yeah, then there's, as I said, there's ideas for the rest, but to do the rest, the other steps, you need to have a base system which is reproducible. And as I said, Perl and Bash are at the moment in Debian the blockers. And even for the key packages, which are packages which are installed by default and used in the distro, which is like 2,000 packages in Debian, there's 180 packages unreproducible. These really needs to be fixed first. And yeah, please help. And that's it from our side. Thank you for your time. Thanks for your contributions. And we hope that you join us on the journey, maybe a bit, maybe a longer part, whatever.
We can take a few questions if you want. Yeah.
Hi, Holger. Oh, is it working? Hey, testing. Okay. Hi, Holger. Hi, everyone. I saw that those timestamps. You said that those issues. So that for me like sounds like a warning. So can you give us some samples on how people are adding timestamps on their stuff? So
one often example that
is in the source code how people are adding?
This software was built on this date. That's an info dialog box. It used to be an info dialog box. Or
okay.
Often, sometimes it's just in the some example script is generated. And in this example file header, there says created on date. And if you run it later, it has created on a different date.
Okay.
And this you can do with source date epoch. You replace this build date with source date epoch, which is the last modification of the source, which is either in Debian changelog, in Arch Linux it's elsewhere. You can use the last git tag, and this is the last modification of the source. and then you replace the build date with that date, and then it's okay.
Additionally, like one of the big, we've found fixes for a lot of the timestamp-based issues. I think it solved roughly, it's the classic, the first thing you solves like 80% of the problems, and timestamps was pretty much that thing. And we fixed it for things like, we fixed it for things like GCC and I think some other compilers, but there's still a lot of like documentation generating tools that just really love to embed the date this document was generated, which is not really, as we've said, all that useful. And that's, I think, and while you could say, well, we just don't build with the documentation, well, PDF's practically a Turing-complete language, so you want the documentation to be reproducible as well. But that's a big blocker right now.
Yeah, we don't make a difference between documentation and code, because documentation can be code, and it's also easier to just compare the whole Debian archive, the whole RPM archive, and not go in there, because these tools also can have problems. So Signal, once released the Signal, the messaging app for Android, they released Signal is reproducible. We have this tool to compare. This tool will exclude some regions which are not important. And then in this tool there was a bug. And that's why we compare the whole thing.
Okay, thank you.
Anyone? You want to add something?
Well, if we have some more time. We have another small video prepared which we could show. We still have 10 more minutes or something.
I think it's possible. We're having a coffee break next, so.
And also, if you find more questions, we are still here for the rest of the day. I'll plug in the audio.
You have 9 minutes.
Is anybody in the room aware of whether software that they work on is reproducible or not? Nobody. Nobody has any idea. So we have a site called test.reproduciblebuilds.org, test.reproducible-builds.org. And on it, at least in Debian and also other projects, you can search for the packages that you might work on. And look for something you're interested in, and if you want software you work on to be reproducible, you can follow up with that. That would be one great way to make a contribution in something you're already working on. So who in here writes a software project that's like published and used by other people? Yeah, handful of people. Awesome. So we would love it if you could take a look at those pages. It looks like the video is ready.
I didn't make the video. There was people who made the video and cut it and did all this stuff. I'm just the actor.
Ich bin Holger Levsen. Seit 5 Jahren arbeite ich an Reproducible Builds, wo wir die Lieferkette für Softwareproduktion sicherer machen wollen. Das soll dazu dienen, dass man dann sicher sein kann, dass die Werkzeuge, die das bauen, dass da keine Hintertüren eingebaut sind, dass die alle dasselbe machen. Programme heißt, ich baue ein Programm, ich kann von Zahlen ein Programm aus, das dieselben.
Do you have any more questions?
We can take one more.
Thank you for the talk, by the way. And looks like most of people here used to develop a proprietary software. And how is for you to add a job related for doing reproducible build in my own pipeline? It's a hard task. It's a good thing for doing my company or not?
Well, it's the same. You can build your software, and if somebody else builds it, then it should be reproducible. You need to use the same build environment, but that's about it. Then it should be reproducible.
So adding this to my own pipeline, I'm going to support the reproducible builds community as well or not?
You are. The thing is, we had this repro test used by people in the CI pipelines, and repro test has a problem because it uses fake time to modify the date, and fake time breaks many builds. So we want to disable fake time, and that needs somebody to maintain repro test. So that is, again, repro test needs a maintainer. This feature is probably easy to fix, but in general, we want repro test to work better to support it for these build pipelines.
I think I'd also like to mention that really reproducible builds is not it is a specific project, but it really is an upstream project, and so really we need to fix all of the software. So by working on the software you're already engaged in and working on, that is truly a help for reproducible builds.
We've also come to say that you can only be sure that it's free software if it's reproducible. Because else you have a binary blob or whatever, and somebody says, yeah, this binary comes from these sources, but how do you know? And with free software, you can be sure that these sources were used to build this binary.
Okay. Thank you, Holger. Thank you, Vagrant.